following question states that isomers F and G, where G is given as C5H10O, both form an orange precipitate when reacted with 2,4-dinitrophenyl hydrazine. And F is an unbranched and reacts with alkaline aqueous iodine to produce a yellow precipitate. And G does not react with alkaline aqueous iodine. It contains a chiral center and produces a silver mirror when warmed with Tollens reagent. The first part of this question reads that you need to name the yellow precipitate produced by the reaction between F and alkaline aqueous iodine. Now remember this, that this over here is your iodoform. Whenever you react it with alkaline aqueous iodine, this is the iodoform test. Now let me remind you that this iodoform test is specifically used to identify two molecules that contain the following structure. Either there should be a methyl group next to Chiral bond or a methyl group next to CHOH. The rest of the molecule could be anything. So these two structures are going to be identified using the iodoform test. And in both cases, this methyl, in both structures, this methyl is going to break away, and this is going to form a yellow precipitate of CHI3. Whereas this is going to be the yellow precipitate, and what's going to happen to this other carbon in both cases over here as well as in this structure over here, this carbon is going to be converted into a carboxylic acid, and it's going to be converted into, this carbon would be converted into a carboxylic acid. But since the conditions are alkaline, you'll get the carboxylate ion instead of the carboxylic acid. So this is the iodoform test. Now the first part is name the yellow precipitate produced by the reaction between F and alkaline aqueous iodine. So that yellow precipitate is going to be CHI3. So it's going to be CHI3 solid yellow precipitate. Or you can, since the question states it wants you to name it, the name of this compound is triiodomethane. In the next part of the question, you're supposed to give the formula of F and G. So let's start with F. We know the molecular formula, which is C5H10O. F is unbranched, which means all the 5 carbon atoms are going to be continuously arranged. There would be no branches. The other thing is it reacts with alkaline aqueous iodine to produce a yellow precipitate, which indicates that it has a successful iodoform test, which means that either of these structures would be present in F. So I've drawn 5 carbon atoms in a row, and one of these structures would be present. I'm going to go with this structure because C5H10O. Let's see if I get the right number of atoms with this structure. So there's going to be a methyl. So let's put a methyl over there next to a Chiral bond O. So this structure is present, and this is the rest of the molecule. This carbon over here would be bonded to 2 hydrogens. This carbon over here would also be bonded to 2 hydrogens. This carbon atom over here at the end would be bonded to 3 hydrogens. Now let's try and count the total number of atoms. There are 5 carbons already. Hydrogens, that's 3 plus 2, 5. 5 plus 2 is 7. 7 plus 3 is 10. So there are 10 hydrogens, and there's 1 oxygen. So this structure looks perfectly, it matches C5. We are getting C5H10 and O. You can try going with this other structure, and you would notice that the number of atoms would not be, the number would not be correct if I go with this other structure. I would have more hydrogens if I go with this alcohol structure. Now let's try and figure out what G is. G does not react with alkaline aqueous iodines, which means that either of these structures is absent. It's not going to be part of G, and the other one is it contains a chiral center. So we need to make 1 carbon chiral. So it has optical isomers, and the other thing is it produces a silver mirror when warmed with Tollens reagent. Now this Tollens reagent is used for oxidation of aldehydes. So which means that G is an aldehyde. So let's start drawing G now. I'm going to start off with it being an aldehyde. So let's start off at that point. The other thing I need in G is that it must have a chiral center. So let's work on this neighboring carbon atom. Let's try and make it chiral. So I'm going to I'm left with 5 carbons. So 3 carbons. What I can do is I can have a CH3 on one side, and I can have hydrogen on one side, and I can have CH2, and then CH3 on the other side. So all four groups are going to be different around this carbon atom, and this will make this carbon atom. It's going to make this carbon atom chiral. So the star that I've drawn, that's the chiral carbon atom. So it's an aldehyde. It has a Tollens. It has a successful test with Tollens reagent. Plus the other carbon atom is chiral. So hydrogen on one side, CH3 on the other side. 2 carbon chain on the third side, and on the fourth side there's an aldehyde group. So all 4 groups are different. So this carbon atom is chiral. In the next part of the question states, explain the meaning of the term chiral center. So we need to define what a chiral center is. A chiral center is a carbon atom. When a carbon atom is bonded to 4 different groups, is bonded to 4 different groups. As an example, now I've drawn the above example of this particular chiral carbon. It's bonded to 4 different groups. It's going to have a tetrahedral arrangement. One bond coming out of the page, one going into the page. So all the angles are going to be 109.5 degrees. So whenever carbon is bonded to 4 different groups, this particular carbon is going to be called a chiral carbon atom. And the special thing about this particular chiral carbon is that there's going to be a mirror image of this molecule that would look exactly the same, a reflected mirror image, but the orientation of the bonds is going to be different. So there would be 2 isomers called optical isomers or enantiomers whenever there's a chiral carbon atom, and there would be 2 different arrangements of the tetrahedral structure. Both of them would be mirror images of each other.